So my name is Panos. I actually work for the Azure.com web team. We're building their website. And my role there is a software engineer who also does DevOps for the team. So I'm going to start from the part where we do the development all the way to maintaining, running the website, deploying the website, and all the steps in between. Before I go there and actually turn out being that guy, is that I have to do a small statement for our legal department, which is opinions are personal in this presentation, and they should not be used as a guidance unless you know what you're doing. Otherwise, legal will be chasing you like that. So I just have to give you a bit of disclaimer before I start. So, how many of you have seen the Azure.microsoft.com website? Fair enough. How many of you actually use Azure? Okay. All right, so let me just give you a quick tour on the website, which is what I'm going to talk about, and then we can go from there. I'm going to use the browser that we are promoting out there. Obviously. And let me just, I don't know how it's going to look there. Oh, it looks good. Okay, so that's the main website. That's the main face. Whenever you want to start using Azure, basically, you are going to end up to that website. You're going to start looking around, find the services you need. There are three major features in the website that we like a lot. One is the documentation. You can find the documentation for pretty much every single service on the website itself. The second one is the pricing calculator. That's something that everybody is using. And I cannot see my screen here. So about 2 or 3 months ago, we released a new version of the pricing calculator. You can find most of the services. We're onboarding all of the services until the end of the year. And then you can start doing all the calculations for that service that you like. You can find the different tiers that they're there. You can do how many instances you want, and so it goes on. Ignore the number. That's a big number, which is kind of true, though. But anyway. And as I talked before, the documentation is also here. We have the documentation for all of the services. Let's see the documentation, for example, for app service, which is what I'm going to show you today, which is what we're using to run the website, specifically the web app. And then you can start looking on, how you can do actual deployments of web apps, how you can scale those, how you manage them, monitoring, and all those things. One important detail here is that all the documents you see here, they actually exist on GitHub. So if you want to contribute towards that document, fix it, update it, even provide your own documentation for something that it's missing and things like that, all you have to do is just fork our repo, do a pull request with whatever you want. It will go through a very simple process of us validating that your MD is correct, and then that will be eventually surfaced up into the website. So all the names that all the faces and the names that you see here, those are actually contributors of that specific article, both internal and external people. Pricing, as I said, was the other one, and the last one is the marketing pages. This is effectively where you will get more information about a service. You will go, for example, on the web apps. You will see the languages that we support for web apps. You can even create a small one directly from here. And then you can read more about it. And in the end, if you want to get started, you can initiate the trial process directly from the website as well. So let me just get back into my slides. So that was a small quick tour about what the website is all about. I haven't touched a lot of areas. I just wanted to show you the three major things that usually people are using: products, documentation, and the pricing calculator. So some quick numbers. Again, I cannot give you the real actual number, but I can just talk in quantities basically. We have thousands of concurrent users every day on the website. We actually get that information from Google Analytics and plus some other services we have, but we're using GA to get that information, real-time users, plus all the funnels and how they're using the website. Millions of page views per day as well. Hundreds of contributors, both internal and external, on documentation and the website as well. We're running on all Azure regions, all the public Azure regions, I should say. There are 18 right now, plus 2 in China that they are public, but you need like a special agreement to be able to deploy there. Then we have the federal government clouds, which are specific to, that was me? Oops, okay. So the federal clouds, and then we have more regions coming up. We announced 2 more. One is in Canada, which is going to be until, I think, mid of next year. And then we also have one in Germany, which was announced a couple of days ago, which is going to be by end of 2016. So we're actively expanding, adding more regions, and so goes on. And the most important number for me, that was up to Friday. We release daily at least once, which means we have at least 561 releases. That's since April 2014. So every single day we will release at least once. I say at least because there might be cases we do 2 or 3 releases, depending on, let's say, how stable our code was when we did the release. And the team is 6 software engineers, both backend and frontend. Some of them are a bit more dedicated on the frontend, some of them a bit more dedicated on the backend services. 1 software engineer, which is me, wearing a DevOps hat. I'm doing more on supporting DevOps operations by creating internal tooling that we're using within the team. 4 program managers, those are not exactly project managers, they're just kind of driving where the website should go. And then we have 1 principal program manager, which is basically the manager of the managers. So, to get to the actual development, what I will try to do is I will show you the actual code, I will talk about the process, and then we'll do a small change. We'll look at how the deployment model we have actually works. Then I'm going to talk about how we bring this change live to the production website, and then how we maintain it, basically how we do the monitoring of the website and how we can do updates on the website. And last, the actual running of the website. And by running, I mean how do we get more information out of what is running there, like A/B testing and all those things. So, starting with developing, there are a couple of Azure services we're using. Those are like the major ones. We're using some other ones that they're not listed here because we don't have a huge dependency on them. And so the first and most important one is Azure App Service Web Apps. This is effectively our hosting container, if you like. This is where the website runs. The guys who are familiar with Azure probably know what web apps are. For those who aren't, this is like a really simple hosting solution, simple in terms of how easy it is to deploy, not in terms of the features you get out of it. You really just get an address where you can do FTP or web deploy. You just push the website there. You select on how many instances, basically how many servers you want to run that website, and then it just lights up. And it supports, obviously, .NET, Node, Python, PHP, and other languages through handlers. Basically, everything that runs on iOS and Windows, it can run on web apps. It can run as a web app. We're using web jobs. Those are for long-running tasks. I'll get to that point as I go through. Azure Storage, I guess it's pretty obvious what storage stands for. Azure Cache, which is based on Redis Cache. It is like a Redis as a service plus a lot of information that we're offering on top of it and a lot of services we're offering on top of it, like ability to auto-scale it, move between tiers, basically upgrade the availability you have on Redis, creating the clusters in an automatic way, and so goes on. Azure Search, this is a Lucene-based offer we have, where you can effectively index and do search on whatever resources you provide to search. Media services, transcoding video, and all the videos that we have there, they're being provided through media services. We do use virtual machines, which is like, the lowest tier you can go in terms of what you can manage in Azure. There are very, 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 very few services we run there just because they cannot run anywhere else. And then SQL database, obviously, and DocumentDB, which is exactly what it says. It's a document database. Extremely clever name there. So we do have a lot of third-party services and tools as well. I'm not going to talk for each one of them. If you just want to take a quick look on those, the most important ones that I want to point out is obviously GitHub and TeamCity and MyGet, then browser stack to automate our functional tests, load impact for stress testing and load testing. We do that a lot on the website, so we know we're not messing something up. New Relic, and then some other tools like Seek and Slack. Obviously, you know Slack. You might not know Seek. I'm going to show you what Seek is. So what does it mean for us to have the source code on GitHub? Well, what it means pretty much for everybody. Federated contribution model. We do all of our release management on top of that. We're also using Visual Studio Online to do the task management, and then we have automation that bridges GitHub and Visual Studio. So for example, when somebody does a change on our GitHub repo and does a new commit that is related to a task in VSO, in Visual Studio Online, they can reference that task within the commit, and then our automation bot will just create a link between those two. So you know that the actual commit, that actual PR in GitHub is related to that VSO task, and the other way around. So if you want to have a VSO task that links to a specific repo, you can actually do that without creating a commit. So the idea is that when we go through either of the tools, we can easily cross-reference what's going on within the code. Using VSO also gives us the ability to see those tasks and the contributions that happen to the code within Visual Studio. There is this small HUD on top of the code that shows you how many references and how many contributors that specific code has, and that specific line or even that specific function. We might be able to see that later, it depends on how time goes, but I can show you why we're trying to do this cross-reference. GitHub significantly lacks when it comes to managing tasks. The issues and labels are not enough when it comes to a site like ours. So we needed something that bridges those two worlds because we like both. So another thing is comparative views. Obviously, like we can see what happened between commits, and then we can track those actual changes as commits are happening. We do use their API for automation. One automation that I reference is that one. The other one is was the VSO reference. The other one is that we're automatically tagging the builds when we're done. Production releases or staging releases or staging builds, depending on the type of release we're trying to do at that point. And it's also kind of important when we want to attract external people because there is a lot of appreciation on GitHub and let's say less appreciation on Microsoft products. So it kind of works well for us on all fronts. So talking about the backend, obviously it's .NET based. It's a Microsoft language. We're using C# for all those. We're using Autofac as an I/O container. We used to use MEF, which is the Managed Extensibility Framework. It's a product by Microsoft, which is not exactly ideal in that case. So we started using Autofac for the website. Serilog, is anyone familiar with Serilog? It's just another very good logging library. Let me put it that way. It allows us to do multiple outputs from the same library, and it's the less invasive one we found in terms of how easy it works with our code. the idea here is that we're logging on multiple places, and because we do that, we want something that it's not super intrusive in our code. And Serilog also is the one that has output to seek. You'll see what seek is. I keep mentioning that, but we'll see it a bit later. Now, one super important detail that makes our site a bit unique is that we don't have any database supporting the website itself. So everything on the website is metadata files that are part of the project, and that's pretty much it. So we don't have any dependency on actually reading from a database what we're going to render in the website. We just render everything during build time based on the metadata files we have there. And the metadata files are basically JSON files. They're not anything more than that. They just describe the data that we have to show in the Azure view, and we just cross-reference what's going on between the JSON file and the Azure view, and then we create the final HTML and show that to you. Once that happens, that stays in memory, and it also goes into Redis. So they're like, if Redis goes away, we can still serve it from memory. The memory one has a timeout, so which means we don't eat a lot of memory, but at the same time, if we lose Redis, our website doesn't die, right? So what I'm trying to say here is that we take dependencies extremely seriously within the team, and we go by a simple motto, which is own your dependencies. So the fact that the dependency went down should not mean that our website is down. We cannot use that as an excuse. We cannot say, hey, Azure Storage was not working. They will be like, it's your problem, not Azure Storage problem, right? So it's kind of a different way of thinking how you're getting dependencies, because basically the pointing finger thing just goes away, right? We cannot do it. We cannot blame somebody else. Although it would be easy to blame somebody else. But so that's when it comes to the views themselves. Like I described, like how the system works. Then we also have the localization. We're localized in a lot of languages. We're using the built-in MVC way to do the localization. We're using regex files. So when I open one of the Azure views, you will see references in the resource files, the regex files, which just basically get resolved at runtime. When the user just changes the language, we just refresh the website. This is a built-in MVC thing, ASP.NET MVC thing. So there isn't anything special there. It's just the way we use it. Obviously, we do have long-running tasks, right? So we have what we call pumps, and that's a name that the team came up with. I don't know why. They just like the idea of pumping, I guess. So what pumps are doing is, you've seen the documentation on GitHub, right? We need a way for that documentation to get into the website and be rendered as HTML. So we cannot just take MD and show you MD there. Markup language is not fun. So what is really happening is that we have web jobs that they will communicate with GitHub. They will take that information out. They will transform it to HTML, and then they will output that into another place, which is basically a storage account for us. We will take it from the storage account, and then we will put it into the website. Now, that process has to happen for a couple of places. One is documentation. The other one is the marketplace. Then it's the site itself, and so goes on. So, for example, when we want to index the site, we'll generate a couple of messages for each one of the pages that we want to index for search. And then this will get queued up into a storage queue. And then the web job will pick up that message and start parsing the site, handing that job off to search that will do the actual indexing. So we're kind of throttling what goes towards to search and what goes towards to Redis, so we don't kill those services, because during indexing and during the population of data on Redis and search, we need a lot of throughput. But at the same time, when the site runs, we don't need that much. So it doesn't make sense that we pay for the burst scenario. We only want to pay for the running scenario. So we're just kind of throttling what goes towards those services by putting queues in between. The benefit of using web jobs is that this queue integration thing, it comes out of the box. So by using the web jobs SDK, the only thing we have to do is create a queue trigger which just points to that specific queue, and then WebJobs will do the rest of the magic. It will pass that message as a parameter to the WebJob, and then we can just read that parameter and do whatever we have to do. So you don't actually have to do all the plumbing of going to the queue, getting the message out, handling timeouts and all those things. You just don't have to do that. WebJobs SDK does that for you. So it just kind of simplifies the way we're working with it, but at the same time, we're not losing control, because if we want to go directly into the queue, we still can do that, right? So it's not completely abstracted away from us. It's still there. It's just being automatically handled. Another example is blog posts. So, yes?
Sorry, what's the storage mechanism for the queue? How's the queue implemented?
It's Azure Storage. So Azure Storage Queues is what we're using for that. And depending on the model you choose when you create your storage account, it provides different levels of redundancy. In our case, we have the highest level of redundancy, which means it lives within the data center on at least 3 replicas. And then it also gets geo-replicated on another region, which is at least 200 kilometers away, which means that if the whole data center dies, we can still continue operations on a read-only mode, but we can still continue working. So, another example is blog posts. We're doing a similar thing for blog posts, but the pipe here is kind of different. So the blog is actually based on Orchard. So we're creating a custom module on Orchard that pushes a message into a queue, which is then picked up by a web job that starts all the population of the cache and search as well. And then once that is done, we're allowing the blog post to be visible to the world. So it's kind of a different pipe. And there was a fundamental issue with both of those approaches. One was that we were killing the API of GitHub all the time. So we were getting rate limited like crazy because we had a lot of jobs. As I said, we're running on 18 regions. So we have 18 different processes trying to access the same GitHub repo. Not fun. So we came up with a different idea, which is we created a global singleton pattern, which uses storage as a lease. So basically, we go to storage and we try to take a lease on a blob. Whichever of the jobs takes that lease first, it just keeps that lease for that specific blob, and the other ones cannot access it, which means the other ones should not reach out to GitHub. And then we start reaching out to GitHub, getting all the information, doing the parsing, and continuing from there. The problem with doing that for blog posts is that it gets time until the blog post is visible. And for example, there were marketing releases and the blog post will be late for 15, 20, even 30 minutes sometimes, and which was not fun. Like they came back to us and it's like, why is it taking so long until we're getting to, to publishing the information? So we kind of changed that approach as well. There is a way now to force the web jobs to do a refresh. So at the moment the blog post is there, we're just funding out the message to all of the web jobs and we're like, refresh now. And then they will start refreshing, and we went from about 30 minutes to 5. So a blog post now gets live within 5 minutes, which is still not ideal because in cases of emergencies like outages and things like that, we want that to happen within like a minute, not within 5 minutes. But you get the point. So getting to the front end, obviously we have HTML, CSS, and all those things. We do use React.js for the pricing calculator. So the pricing calculator is based on React. And we do have an internal JavaScript framework, which is called Sandog, and it does a couple of things. It's not available as open source yet, so there isn't much point of talking about that. But one important detail about React is that we're compiling the JSX files to JavaScript files before we do the actual publish. Why are we doing that? Because it takes time to do the compilation on the browser. So compiling JSX files on the browser side, it takes a lot of time. And when you have to do that between multiple languages, then it adds even more time. And then when you have to bundle this for languages, like creating the bundles for that specific language, that adds even more time. So our startup time was crazy when we started doing that. So we just found a solution where we built our own JSX to JS converter, which runs during build time, and it creates the bundles of React modules during build time. So we don't have to do that at runtime. There is another process which is called localization drop-off. What that process does is that it gets the regex files out of the code, then it publishes those to an internal portal. Then the teams that they're responsible of translating those will see those localization jobs. They will do the localization. They will publish back to GitHub as a PR request. And then once we merge this PR request, those will be merged back into the code. So the localization process is completely independent from the development process. They just get regex files, they do the localization, we just merge them back in a completely automated way, so we don't ever have to touch anything when it comes to localization. It's up to the loc teams to do it. The only thing we care is the English language and just getting the thing out. Let me just show you our GitHub repo. Yeah, it's a private one, so you'll see the address, but there isn't much I can do about that right now. So you can see a bunch of numbers here. We have a lot of commits, a bunch of branches, and then 967 releases. That's a significant different number. Oops. What about, yeah, sorry. Yes, get here. There you go. Okay. So now I don't look stupid. So 28,000 and something releases, 132 branches, 28 and something thousand commits, and 967 releases. You might see the difference between 561 and 967 in terms of releases. That's because I said we're doing this at least once. There are days that we do that more. We might do multiple builds. Each one of the builds is a release for us. So this is what it's going to be in production on Monday. This is the staging build 1591, which means 1,591 builds. Once that gets into production, then the automation bot will mark this as a production release, and then we can see, what was into this release if we open that one. We can download the source code that was for that specific release, so we can always go back in time if it's necessary, without even have to look into the code repo. And there are a bunch of other stuff that you might be interested here. We have a couple of pull requests open. You can see we're not using issues at all. I said we're using Visual Studio Online for that. And that's pretty much our GitHub repo. I mean, if there's anything interesting that you would like to see, or anything that draws your attention, just let me know, and then we can just open that up later, and we can take a look at it. So that's the GitHub repo. And then I do have our code locally checked out by Git. So it's kind of a deep path, but it doesn't matter. And let me bring VSO code online. So I'm not going to open the whole Visual Studio. It doesn't make sense just to show you a couple of lines, and so goes on. I do have the index Razor view open. You can see the resources reference that I was talking about, which is effectively the regex file that gets loaded for that specific culture. And then this is the reference to the resource file to do the localization for the content. Do you know what Visual Studio Code is? Okay. I'm happy. I was actually working in a team that was related to Visual Studio Code and a couple of other things before joining that team. So, all right. So as you can see, pretty standard HTML, nothing crazy. We do have a couple of helper methods that do the localization, for example, for the URLs. And then there is some other ones a bit lower, which do, where is it? I can find it. Anyway, it doesn't matter. Oh, there you go. Oh, no, it's not that one. The SVG helper that just outputs the SVG files for the backgrounds and all the carousels and all those things. So nothing crazy there. Pretty standard MVC, Razor views, and HTML. So getting to the part where we do the deployments, it used to be a scary process for us. And I say used to be because we kind of changed that a couple of months ago. The process used to be that we were not obviously running on all those regions, so we were just kind of using a built-in webapp functionality. Webapps provide you a built-in GitHub repo where you can just connect directly to that Git repo, where you can just connect directly to that Git repo within the web app, do the deploy, and then it will also do a build and then deploy that website for that specific web app that you're targeting. So we will have 3 or 4 web apps. That's like 3 or 4 different regions. We will go repo by repo and then deploy there, let it build, and then bring the website online. But once we went to 15 and now 18 regions, that model doesn't work anymore. Like going one by one takes forever. That's one thing. Second thing is that if something fails, what do we do at that point? Do we roll back or do we go forward, and so goes on? So we kind of introduced a way to automate all those things. We started using TeamCity to manage all the deployments. The idea is that we really wanted to go to one-click build where you just provide the parameters you want and then it just does what it has to do to get the website out. And that also allows us to prototype a lot of things faster. There is a building process where once you do a PR request or you create a new branch to the GitHub repo, we will actually create a website just for that PR and just for that repo, just for that branch, with the changes that you did there. We will deploy that and we will give you the address so you can go verify that everything is okay. So for each one of the pull requests and for each one of the branches, we're creating separate websites that they have a naming convention based on the feature or the PR number. And you can just access that website yourself and you can basically verify what's going on. So we're creating and destroying a lot of web apps every day because of all these pull requests that they open and they close. So when you close something, we are actually deleting the website. When you're opening something, we're creating a new one and putting your code there. That process also repeats every time you do a new commit. So when you do a new commit to that repo, then we'll see that and we'll rebuild and redeploy, rebuild, redeploy until you're done. And then you'll say, merge it to the master or create a request for us to merge that specific branch into the master instead of just a PR to the master. And once you're done, then those changes will get live to the website eventually. Continuous integration was the other thing. So every single time there is a commit, we're rebuilding master, we're running all the tests and so goes on. That happens every single time a commit happens in the master. We try to keep master green. It's not very easy because we're rapidly changing every day. The thing that breaks all the time is our tests. So people don't like that a lot. At the same time, we don't have a lot of time to fix all the tests. So there are cases where we just know that the test is going to fail and we just ignore it in an inspection within TeamCity. So we just say it's okay. I know this is not ideal and we're trying to fix that, but at the same time, it takes a lot of time and we're not enough people. So we just kind of try to find a balance between those two. And the other thing by running within TeamCity is that we can create our own customizations and basically create our own automation tasks for as build steps during the build time. We also use TeamCity to do the deployment itself, and I'm going to show you how we do that later. So one thing for sure, we're not deploying directly to production. So we're not going directly to the website that you guys are seeing. we're going into what web apps call slots. And we're using 2 different extra slots on top of production. So we have production, staging, and previews. You will get what the previews is as I go through the process. And what it really happens is that once we create something, like the new release, we will deploy that to staging. And then we will start validating that everything is OK on staging. We will send that address out to the stakeholders so they can go and look at their changes, that everything is OK, and so goes on. Our test team, which is based out of somewhere in Asia, I don't remember where, they will do tests during their daytime, which is during our nighttime. So the next morning, we can just verify that everything is still OK, and then we'll do what we call a swap. There are 2 issues there. One is, how do you separate your resources like certs and Redis between the slots? Because, for example, we don't want the index from staging to show up into the index of production, because in that case, we might reveal information that it's not supposed to be revealed until the next day. For example, when we're announcing new services, you should only know about those new services tomorrow, not the day before, because we screwed up the index. And at the same time, how do we do this forecasting and basically every single service that we're using? So to get to a point where we separate all those things, we introduced a concept which is called groups. The concept of groups is an extension of a slot, if you like. So each one of the slots, they have dedicated resources. So we have 3 instances of Redis, not only 1. We have 3 of them running. Then we have 3 different indexes for certs, each one for the slots, and so goes on. So what really happens is that we resolve the group during build time. So once we're about to do the build, we will find on which group this build should match. And then we will do the deployment. And once the deployment is done, indexing will run, blah, 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 and all those things. And during swap, the group follows the application. So that means we're going from staging to production. All the configuration will follow, which means all the group configuration will follow, which is what we want, because there is no chance that we will leak information from indexes and searches and all those things. To separate the slots, we're using slot settings. So we can go into a web app and say, this is a specific slot setting. So app service knows that this setting should not move during the swap. It should stay there and only be visible to that slot. And we have one simple setting, which just gives us the name of the slot. So production, staging, previews, that's pretty much it. So that information doesn't move. The rest of the things are moving between the slots. There is a gotcha, though, with that approach. And the most important one is the application pool restarts when that happens, which basically means that once swap becomes production, everything that was warmed up into staging is now gone, and they have to do the warm-up all over again. But warm-up is not fast, right? So it might take 30, 35, even sometimes 40 seconds to bring the whole site up because of all the processes that I explained. So this is causing a lot of problems into our app, because the built-in logic from Azure App Service that warms up your site doesn't follow 301s, and we do 301s to force HTTPS, one thing, and the second thing is to force culture. So you should only see the culture that you're supposed to see based on your browser settings or based on the override you did on the website, not just English US all the time. So we do redirects for those things. And we had to come up with a solution, because after every swap, we did had terrible times when it comes to response times for a couple of minutes until the whole throughput was going up. What made things even worse was that if you use output caching and then you swap, you have to bust that cache, right? You should not keep the output cache you had from staging. You should rebuild the new one for your production environment, which means that a lot of requests will go to the backend to be able to rebuild that output cache. So the combination of a long warm-up time and a cache busting just picks our throughput requests to about maybe 30 or 40,000 requests per second to be able to build everything up until we're done. So that was a lot of stress going on into the infrastructure just by doing a simple thing of just bringing something new up. So we needed a solution. We went back to the team and we were like, this is not like how it should be. We really need a solution. And there are two different ways to do that. One is you can use a feature which is called swap with preview, which is exactly what it says. So you will do the swap, but it will not make it visible until you can verify that everything is okay. So that's one way. You bring staging to production, which means all the settings of production are now applied to your code, but that code is not visible to the outside world. So you can go, you can verify it, you can do whatever you want, including warm up, and then you can say finish, and the only thing that will happen is that it will just flip the internal load balancer switch, and it will make it visible, and that's pretty much it. The other approach is to use the IIS application initialization module, which is what we're using actually. And we're just specifying the English culture as the warm-up point. So it knows that it will go there to do the actual warm-up of the site. And to avoid the HTTP to HTTPS redirect, because the application initialization module only works on HTTP, we're checking, based on some guidance the IIS team has out there, we're checking the user agent, and then we're not redirecting if the user agent is from the module. So if you do want to do warm-ups, independent of if you're running on, on Azure or not, if you're using IIS and you want to do warm-ups, you can use, for example, the application initialization module to warm up a lot of different endpoints. That might mean warm up your cache and so goes on. In our case, that didn't matter because the caches and the certs are already warmed up because of the web jobs process we have running. But in your case, you might want to do some requests and things like that. So let's say that we are ready to go live and we want to bring everything into production. Staging is fine. We did everything okay. So we have a simple process. Our swap now takes staging and makes that production. And then we're taking production and swapping it to previews. So previews is basically yesterday's production. Why are we doing that? So we can immediately have the ability to go back if something is wrong with our production website. So there have been cases where it wasn't the fault of the code, but there was configuration errors on the production release that we have to go back to the previous version, fix that, and then do the whole process of deploying to staging, swapping, and then doing the whole thing all over again. So that's, in our case, let me put it simply, if we go down, everybody thinks that Azure is down, which is a really bad perception. So we're trying to be careful when it comes to doing all this process. So we always need a way to go back to whatever it was, our previous production. And once we're done, we can deploy the new version to staging. So for example, now version 138, we'll go to staging and then we'll do this process all over again. There is a challenge though here, which is how do you do the swap across the globe? We're talking about 18 regions. Swapping one by one will probably take you, like including the swapping time, probably take you about 35, maybe 40 minutes until you go through all the regions. Just by calculating 2 minutes per swap, which is usually more, but let's say that it's only 2 minutes per swap, right? That will take you about 40 minutes to do the swap across the globe, which means that a lot of sites will be out of sync. Like people in the US, they see the latest changes, and the guys in East Asia, they might see it after 40 minutes, which is not good when it comes to marketing releases, new services, and so goes on. So we really needed to be able to swap across all regions. We also needed a way to handle transient errors, like how can we retry when a swap fails? Because there might be like the network timed out, things like that. That's not really a failure that should stop the process, right? Which is just restart for that one. So what we did is we built a custom tool, which we're using it in a lot of different places. It's called Builder. And that tool has all this logic in there, and it does a simultaneous and asynchronous swap across all regions. So it fans out to all regions, and then it says swap. And then it monitors what it's really happening, and if there are any errors, it will retry. It will keep retrying until we reach the max retry count. And if that happens, it will only tell us which regions failed, and then we can just manually go in and debug and see what is going on. So how do we do the actual maintaining of the website? So there are two things here. One is when things go wrong. One is a hotfix. Hotfix follows exactly the same process as every other release. The fundamental difference here is that a hotfix is a branch based on yesterday's staging. So whatever was in staging, which is now production, our hotfix is based on that branch. It's not the latest thing we have in the repo, because the latest thing in the repo might have releases for the next day, which should not go live. So we're basing the hotfix based on the current production release we have there. So that's in case we did something wrong. There is the case where our platform is not available, which is, likely to happen. And we kind of embrace that approach. So whenever there is a region failure, so a region goes down or a website is not available there, we're going to remove that from the DNS rotation. And the DNS rotation pings the websites every 5 minutes to see if the website is there, if it returns 200 or 301. And if it doesn't, then it takes that site out of rotation. So it means it doesn't get any more traffic in that specific case. The little catch here is that has a 5-minute time to leave. So there might be a case where a customer might not see the site for maybe 8-9 minutes. So if he actually accesses the site on 4:59 and then we remove it, then he needs another 5 minutes until he gets the new DNS address. But this is completely transparent to the customers. They never see it. They always hit azure.microsoft.com, and they will end up in some region based on where they are based in the world, and also based on the availability of the site. So that allows us to isolate the failures. How do we know when things go wrong? We're using New Relic. That's one of the things. We do have internal monitoring, internal tools and whatever, but we're using New Relic to do global and regional monitoring. There are different alerts based on each one of the regions. We need different alerts for global than we do for local, because the aggregation significantly moves the failure rates. 80% failure rate on global level is a catastrophe compared to an 80% failure on a regional level. So that's something we're really keeping in mind. And we have different tiers of how we go and look into things. One is we have SIG, which is an aggregation of our logs. I'll show you SIG right after. Then there is a web app where it has the ability to do streaming logs. So we can go into the web app, we can enable logs there, and then it will output all those logs into our console real time as the requests are happening to the web app. This is a built-in Azure feature. This is not something we did. You just have to enable it for the time that you want, and then you can see all the logs going in. And the last step, which is very rare, but we still have it, is plain vanilla logs, application and HTTP logs. Those are getting persistent into the storage account and also in the local file system up to 30 minutes, I think, on the file system and forever on the storage account. So if we want really to go back to the actual HTTP request, we can do it. It will take a bit more time, but we can do it. So let me show you SIG. I kind of masked the host because you're not supposed to see the actual host. But so this is an aggregation of all our logs. Serilog actually has a way to connect to SIG, and then it outputs directly to SIG. And then within the SIG server, we can go and see all our logs. For example, there is one deployment now. ACOM jobs in West India could not find that specific offer information for that plan, right? So we actually see that information. CDN did a fallback somewhere because it was not available for that specific hotfix branch, which shouldn't matter at all because if the CDN is not there, worst case scenario, we just go back to the website to take information. This is like the searches that are happening on the site. So there is a bunch of information that we can get out of Seek, and then we can filter that information. We can also see the production environment. This is the regions that we're running. We can just start drilling in. And then there are other things we can do. We can just say, give me all the things that are containing the word cache missed, for example. And then it will just search the whole thing and just give us only the occurrences of that one. We can also open this one and say, hey, you know what? We only want to see things that are in the branch hotfix. So this will only filter that specific branch. So you get the point, right? You can do a lot of things in here. You can also tune the level of verbosity you want there. In our case, we have this now on warning level, but you can get it all the way up to verbose, and basically everything that happens on the applications worldwide get aggregated in real time in the server, so we can see everything that is happening real time. The other feature is the streaming logs. Come on. Thank you. So now that makes it a bit tricky for me here. Hey, where is my shirt? Let me refresh. You don't like it, okay. How about now? Still? Whatever. So I'll just get here. Actually, no. Let me see if I can find it from here, because I don't want to expose something that I'm not supposed to. So, US West 2. All right. So, found what I wanted. So this is one of the deployments. This is a shadow deployment that we have in West US. I might not be super visible, but once I get to the feature, I'll let you see that. So this is a shadow deployment. This is not getting any traffic, but it just shadows the production. So if we really want to do debugging, we can just hook up to that one, replay the logs, and then see what's going on. And the feature that I'm talking about is, where is it? Do we? I can't see, sorry. There you go. Now it's huge. Okay, you know what? So the feature that I'm trying to show you, which I probably, yeah, it's impossible. It's the resolution that it's killing. It's killing my demo. Anyway. If anyone is interested to see the actual streaming log thing, you can just pop by later and I can show you that one. And the last bit is how we do how do we run the website and understand the users? A/B testing. We do that a lot. We're A/B testing a lot of different approaches, a lot of different features. And once we understand what the users do between those two versions, we might change designs and make things look better compared to what we got out of the A/B test. Our program managers love that because they know where to invest more when it comes to getting the website to the next level. And there are two ways. We do query string injection to get you to that specific version of the site. And then we do have external tooling that kind of does the whole handling of the A/B testing. Don't know the name because I never used it. Our front-end developers know it, so I just didn't include it here. And then there is another way to not do A/B testing, but do server-side variations. This is super important for us during major events because we don't want to do a whole redeploy just to change parts of the website once the event is done. AzureCon was one of those examples. So we wanted to refresh the actual site of AzureCon without having to do a full redeploy, so customers can go between the streaming to the game and so goes on. If any of you was watching AzureCon, you should have not noticed anything when we were doing all those things. If you did, let me know, because you were not supposed to. And the approach was very simple. Query string that maps to a JSON file which lives in a storage account, which maps to a specific view, a specific Razor view. So what was really happening is that the controller will look for that info. If that info is there, we'll parse the JSON file, which is in memory because it's already loaded, but it will reload that JSON file every couple of minutes. And then it will show the view that it's supposed to show based on the query string that we provided. The whole thing is completely transparent to the user. They'll never see that. This is not meant to release new features. This is mostly for emergency and failover cases, but also for kind of allowing live events to continue without having to bring a whole deployment up. So just to summarize, the things that we did learn. I'm out of time? OK. It's the last one anyway. So automate everything. Things will go wrong, so just be prepared for that thing. And never assume, always do A/B testing. Those are like the things we do every day. So if you have any questions, you can just come up. Otherwise, thank you much, and I hope we did give you some experience. So.